Good day, everyone. Welcome to WiseLink Academy. Today, we want to calculate for the reaction for an overhanging UVL beam. You understand? This is a UVL. We have type of load. Under the type of load, we have uniformly distributed load and uniformly varying load. Uniform distributed load can be identified this way. For instance, this is our beam, isn't it? And we have a reaction here and a reaction here. Likewise, a reaction here, isn't it? So if I have my load this way, I can easily call this a what? A uniform distributed load. Or in this format also, if you have a load this way, isn't it? And you have if you also have something of this nature, take it like this, So such kind of distribution of load. Let's say this is my reaction here, isn't it? So this type of load is called a what? Uniform distributed load. But uniform varying load is what we're going to looking at today, which is this. This is how it is illustrated. So this is uniform varying load. So don't forget that our UDL, that is uniformly distributed load, and they are illustrated this way. So don't forget that. Why uniformly varying load is illustrated this way. Now proceeding. Now we have to find for the reaction. That is, we want to find for the reaction for this what? UVL. Understand? This looks like an overhanging beam, but has a load of what? UVL. That is uniformly varying load. So we want to calculate for this. We want to find for the reaction. How do we go about that? So the first thing I need to do is to what? Draw the free body diagram of this. So let's do that. Now, if I start my full body diagram of this figure, will be, before I start to draw my full body diagram, I need to calculate for the area of a rectangle. The first thing you need to do is what? You draw out this shape you're having. Isn't it? We have something of this nature. What we're having is something of this nature here, isn't it? This you are seeing up here simply means the thickness from here to here is what? 12 kilonewton per meter. So the distance from here to here is what? 5 plus 2.5. I'll be having what? 7.5 meter, isn't it? So therefore, area of a triangle is equal to what? 1/2 times base times height, isn't it? So if I work on this, I'll be having 1/2 times my base is the bottom figure, 7.5 times 12 kilonewton per meter. This per means division. That is, in every 1 meter there is what? 12 kilonewton. That's meaning. Take out this, isn't it? If I cut out this 2 here, 1, 2 here, we are having 6. So we are left with 1 times 7.5 times 6 kilonewton, and finally I'll be having 45 kilonewton. If we times it together, we'll be having that as our 45 kilonewton. That is, I've converted this into a point load. That is, this 45 kilonewton will be acting at somewhere on this beam. So once I'm done with this, the next thing to do is to explain a little term for us. You know, this is a triangle, isn't it? This edge here is called the apex. What did I say? Let me show you what I'm trying to say. This is a triangle, isn't it? Here is called the apex. While here, this edge here is called the what? Head. So for the apex is what? 2/3 times what? Length of triangle. Okay, that now for the head is equals to 1/3 of what? Length of triangle. You need to know all this. Do you get that now? So as I've started into that, it simply means that this is my force here. Now if I'm taking the readings from my apex, I want to establish a point in which this 45 will be on this. Let's proceed. You understand what I'm trying to do now? During my body diagram, you take your meter rule, you draw an horizontal line, this way. This is a pin support, or you call it in support. It has what? 2 reactions, one at the bottom and one at this corner here, isn't it? Why this has what? 1 reaction. It has 1 reaction, isn't it? So because here is point A, I will have this RAY reaction at point A on the y-axis and RAX reaction at point A on the x-axis, as you can see. So here is what? Reaction at point B on the y-axis, because it's a roller support. This is my point B. So if I proceed, I'll be having this illustration. So don't forget, according to what we have on what you are seeing here, the distance from here to somewhere here, let me show you, from here to somewhere here is what? 5 meters, isn't it? As you can see, I'm trying to draw out the full body diagram. From this point here, and this is point C. This point C here, this is here. So from here to somewhere here is what? 2.5 meters. Now I want to relocate this 45 kilonewton. I want it to act somewhere in this beam. So what we're trying to do is what? To convert UVL into point load. So now I want this 45 to act somewhere. I cannot just place it somewhere here. You understand? I need to give it a distance. So now if I'm taking my reading from the apex, that is from this point here, from the apex, I want to take my readings from the apex. So I'll just say apex, that is 2/3, isn't it? That is from the apex to do it here. So from my apex, that is 2/3 times the length, the distance from here to here is what? 7.5. So my answer will give me, I'll be having 5, isn't it? 5 automatically. Now from the head is what? 1/3 times 7.5. That is this distance here. As I said in the formula, this is formula here. So we'll be having, if you calculate it, I'll be having 2.5. This simply means if I want to take my readings from this point C, can you see that I will measure what? 5. So let's say from this point here to this point here to this point here is 5. From this point here to this point here is 5 meter, isn't it? So where it ends will be that point. I see that 45 will be. You get that now? 45 kilonewton. And from the head, that is from this place, if I want to take my reading from this place, I'll measure what? 2.5. So let me just say from here to here is what? My 2.5. So it's just for us to locate where this 45 will be. So now that is from here to this, from this place now to this place is what? 5 meter. That 45 will stand on it, on that point at where it ends. So now if I proceed, I'll be having this. I want to find my reaction now. That's the next thing to do. Finding my reaction. And we can find our reaction using the law of equilibrium, which says summation of H is equal to 0. Let's start with that. Calculating for reaction. So if I want to do that, I'll start with what? Summation of H is equal to 0. So consider this to be positive and this to be negative, isn't it? So if I consider this, what is the horizontal force reaction here? Is already this. So definitely I'm having RAX is equal to 0. Automatically my answer is 0, isn't it? So if I move on, summation of V is equal to 0, isn't it? So consider my upward force to be positive, my downward force to be negative. So if I work on this, I'll be having this a vertical component, that's RAY, isn't it? Plus another RBY, this point here, this one too is vertical, minus 45 kilonewton, isn't it? Is equal to 0. That is, summation V's are all this is equal to 0. This is it here. So if I proceed, I'll be having this mathematically to give me RAY plus RBY is equal to 45 kilonewton, isn't it? Now I'll call this my equation 1. So the next thing to do is to take a moment at a point. So I always advise you should take moment at a point in which that point has 2 reactions. That is, look at point A, it has 2 reactions. So let's take note at point A. So taking moment at point A, that is, let me show you very well. That is, summation of moment at point A is equal to 0, isn't it? Like I said earlier that anywhere taking moment will be what? 0. So, and it simply means, for instance, if they are fighting at point A, all this reaction you are seeing here, this one you want to look at this, and this you want to look at what is happening at point A. But point A is automatically 0, because why? Because we take moment at point A, isn't it? So now the first thing is that this reaction, you want to look at this place, and the easiest way for it to move is this, isn't it? So consider this to be my positive, my clockwise, and my anti-clockwise to be my negative, isn't it? So this is the fastest way for this to move to this place. So it's moving what? Clockwise direction. I'll be having 45 times the distance it has covered is what? 2.5, not from here to here, it is 2.5. That is the excess of what? Calculating for apex and head. So from here to here is 2.5, isn't it? So plus open bracket. The next thing is what? This reaction here, RBY, needs to what? Look at what is happening here, and the easiest way for it to move is to take a shortcut like this, isn't it? So it is moving like it's moving what? In an anti-clockwise direction. So that is minus RBY times what? It has covered what? From here to here is 5. Can you see? So it has covered distance of 5, isn't it? So it's equal to 0 because there's no more any reaction here again. So except 1, 2, that's all the reaction is there. That's why we take equal it to 0. If C has a reaction, reaction, we need to take it 2, but there's nothing at C. So if I work on this, 45 times 2.5, I'll be having 112.5 plus open bracket minus RBY times 5, minus 5 RBY is equals to 0. So mathematically, I'll be having minus 5 RBY plus 112.5 is equals to 0, isn't it? Because plus and minus is what? Minus. So minus 5 RBY. There's an invisible plus here. So this is it here. Is equals to 0. So let me show you what I'm doing. So if I take this to the other side here, I'll be having minus 5 RBY, isn't it? Is equals to 112.5 is equals to minus 112.5, because when the positive sign cross on the side, it becomes what? Negative. So minus cancel out minus mathematically. So let's proceed. If I proceed at this point, if I start from this place, we are left with 5 RBY is equals to 112.5. So divide both sides by what? 5. By 5. So we are having 5 RBY over 5 is equals to 112.5 over 5. So when this cancel out this, I'll be having RBY is equals to, when I divide this to this, I'll be having 22.5 kilonewton. That is, my RBY is this value. So I've successfully gotten my RBY. So it's remember RAY. Recall from equation 1 that says what? This equation 1 here that says RAY plus RBY is equals to 45 kilonewton, but RBY is equals to 22.5, isn't it, kilonewton? So therefore my RAY plus RBY is what? 22.5 kilonewton is equals to 45 kilonewton. So if I work on this mathematically, I'll be having RAY is equals to 45 kilonewton minus 22.5 kilonewton. RAY will be what? Will be 22.5 kilonewton. So therefore my answer will be this. So my RAY is equals to 22.5 kilonewton and my RBY is equals to 22.5 kilonewton. If you want to confirm if this answer is correct, when you add them together, it must give you that reaction you're having upward here. So if you add it to give you what? You're having 45. So this is how to find for reaction for a uniform varying load. So if you found this video helpful, kindly click on the subscription button and like. Welcome to Wise Link Academy. In our next video, I'm going to be looking on how to draw the bending moment and shear force of a uniform varying load. Thanks for watching.